It's moving at a velocity of about 135,000 miles per hour, so it's going really fast. For that distance from the sun, this is really exceptional. You have to be an interstellar object to be going that fast at that distance from the sun.
The object is quite large, and it's also aligned in its path with a plane of the planets around the sun.
Right now, an object from another star system is breaking apart in our solar system. In just 48 hours between late September 2025, Comet 3I Atlas exploded in brightness, growing 6 times brighter than any model predicted.
We will learn much more as 3I Atlas gets closer to the sun. It will be illuminated, it will get brighter since it will reflect more sunlight.
Then, it wrapped itself in a green glow so intense that backyard astronomers could photograph it. And when scientists looked closer, they saw something that violates the most basic law of comets: a tail pointing directly at the sun. The shocking brightness surge. Comets usually brighten slowly. Over weeks or even months, solar heat turns frozen gases into vapor, and the glow builds up bit by bit. It's one of the few things in astronomy that feels predictable. But 3I Atlas broke that rule completely.
All there is to know about NASA's latest observations of Comet 3I Atlas.
In just 48 hours between September 27th and 29th, 2025, it grew 6 times brighter, far beyond anything astronomers had mapped out. This wasn't a gradual rise, it was an eruption. And that changes a lot because brightness tells you what's going on inside the comet. A surge that violent means something gave way. Either part of Atlas's core split open, exposing hidden ice, or some chemical process snapped awake the moment it crossed a heat threshold. Both are extreme, but either way, something deep inside it broke loose. Most of the tools scientists use to predict comet behavior rely on what's called a light curve, a chart that tracks how much light a comet gives off over time. These curves help plan observations, explain reactions, and spot dangers like fragmentation. But Atlas threw that whole system out the window. Its light curve isn't just off, it's shredded. Each time astronomers updated their models, the comet outpaced them again.
And it's already looking like 3I Atlas could be even weirder.
And it didn't stop. After the flare-up, Atlas didn't dim. It held that brightness, which is even stranger, because normally a sudden spike like that suggests the comet's about to break apart. But this one didn't. It just stayed active. Atlas is flying through space at nearly 60 kilometers per second. That's fast enough to cross the distance from Earth to the Moon in just under 2 hours. By the time scientists finish analyzing one night's data, the comet's already changed again. The brightness surge squeezed months of action into just days, and scientists are scrambling to keep up. To researchers, this moment feels like standing on the edge of something we don't fully understand. It's exciting, but also nerve-wracking, because whatever's driving Atlas is not following the rules. Why is it glowing green? When 3I Atlas was first spotted, astronomers looked for signs of carbon compounds, diatomic carbon. That's the stuff that makes some comets glow faintly green.
Their observations showed that the object's coma has now transitioned from giving off red light to green.
But Atlas didn't show any. It looked clean, quiet, and carbon-poor. Within 48 hours, Atlas erupted in light, and something strange happened. That once quiet comet suddenly lit up in vivid green flares, bright, unmistakable, and strong enough for amateur telescopes to pick up from Earth. It was like the entire object had cracked open and switched on. So, what changed? The leading theory is exposure. That sudden brightening wasn't just about light, it may have fractured the comet's outer shell. If Atlas split open, it could have revealed deep, untouched layers that had been sealed for billions of years. And inside those layers, likely carbon-rich ices. buried since the comet first formed in another star system. Once exposed to the sun's radiation, those materials began to vaporize, and that's when the green glow came to life. The green showed up at almost the exact same moment as the brightness surge. That's why scientists think these events are connected. Either the outburst exposed the carbon, or the carbon triggered the outburst. Right now, they're not sure which came first, but they're almost certain it's not a coincidence. The glow itself comes from a known reaction. When diatomic carbon molecules get hit by ultraviolet light from the sun, they fluoresce green. But what's puzzling is how suddenly and intensely this happened with Atlas. Most comets release these molecules slowly. Atlas seems to have released them in a flood. This green haze is a chemical clue that may hold information about where Atlas came from, what it's made of, and how long it's been carrying these hidden compounds. For scientists, it's like opening a sealed container from deep space, one that's been locked since before the Earth even formed. For years, researchers have only been able to guess what's inside most interstellar objects. But now, with Atlas, they can see it happening in real time. And thanks to how bright the glow is, even backyard astronomers are helping capture images. That's rare, but it also means things are changing fast. If the green light is coming from newly exposed layers, there could be more to come. More compounds, more eruptions, and even more surprises. The tail that points the wrong way. There's one rule in comet science that's held true for centuries. A comet's tail always points away from the sun. No matter the angle, speed, or position, solar radiation and charged particles from the solar wind push dust and gas outward.
As insolation ramps up, volatile ices sublimate faster, dragging dust off the surface to form a brighter, broader coma and tail.
The tail acts like a windsock in space, always blown back from the sun. But 3I Atlas has changed the rules once again. Recent observations revealed something truly strange, a narrow, visible feature pointing toward the sun. Multiple astronomers, using completely separate equipment, saw the same thing, and what they saw looked like an anti-tail, a tail going the wrong way. This isn't completely unheard of. Comet Arendt-Roland, back in 1957, briefly showed a sunward-pointing feature that confused scientists. A few comets since then have also displayed faint anti-tails, usually explained by dust particles left behind in a comet's orbital path. From Earth's view, those dust trails can sometimes line up just right and seem to point toward the sun, but they're typically weak, short-lived, and angle-dependent. Atlas is different because its anti-tail isn't faint or temporary. It's sharp and consistent, and it's been captured across several nights by both major observatories and skilled amateurs. That makes it harder to define it as just a visual illusion. Something unusual is happening. So what could cause it? One theory is that this isn't a tail in the traditional sense, but a spray of material shooting out in multiple directions.
And has recently begun to change shape. Its tail has grown longer and its coma.
If particles happen to reflect sunlight more strongly in the direction facing the sunward part might just look brighter. That would suggest Atlas's activity is chaotic and uneven, not the steady, one-directional behavior most comets show. Another possibility involves electromagnetic forces. If Atlas is releasing ionized gas, charged particles, not just dust, those particles could interact with magnetic fields in space. Instead of being pushed straight by solar wind, they might follow strange paths, twist, or even loop back. Some comets do form complex plasma environments around them. And if Atlas has a particularly active or unusual chemical makeup, it could be reacting in ways we've rarely seen. Interstellar objects like Oumuamua and 2I Borisov were odd.
But scientists could not detect all that dust and gas coming from Oumuamua. To be sure, the Spitzer infrared space telescope spent...
But they didn't break basic comet physics. They stayed within the lines. Atlas is going far beyond that. A brightness surge, a vivid green glow, and now a tail pointing the wrong direction, it's building a case that something is very different about this object. If this antitail is real and not just an optical fluke, it could mean that Atlas is made of unfamiliar materials. It might also challenge how we understand the solar wind and how it interacts with objects from beyond our system. Mars gets a front row seat. On October 3rd, 2025,
Next, it's heading towards Mars. It will be closest on October 3rd, and spacecraft in orbit and on the surface will try to catch a glimpse.
3I Atlas will pass just 0.25 astronomical units from Mars, about 37 million kilometers. For the first time ever, an interstellar comet will sweep close enough to be studied in real time by robotic spacecraft orbiting another planet. Mars is currently surrounded by a powerful fleet of orbiters, each loaded with scientific instruments that can capture this moment from every angle. NASA's Mars Reconnaissance Orbiter, MRO, carries HiRISE, one of the sharpest space cameras ever sent to another planet. ESA's Trace Gas Orbiter can analyze the comet's vapor trail using infrared and ultraviolet spectrometers. MAVEN, built to study Mars's upper atmosphere, can track plasma interactions and solar radiation near the comet. Even smaller CubeSats in orbit can detect dust particle activity and brightness shifts in the coma. These machines weren't designed for comet science, but Atlas is passing close enough that they may capture data Earth-based telescopes simply can't. On Earth, astronomers are already battling twilight skies and solar glare as Atlas nears perihelion. But Mars orbiters won't face those problems. They'll be able to watch Atlas against the dark of space, without the interference of an atmosphere. That timing is critical. Just weeks after the Mars flyby,
That's going to be barely inside the orbit of Mars, and then it's going to keep going on its way out of the solar system.
Atlas will slip behind the Sun as seen from Earth. During this superior conjunction, the comet will vanish into the solar glare, making further observations nearly impossible. Mars, however, will get a clean shot, just in time. Scientists are hoping to discover the true size of Atlas's core then. On Earth, that's been hard to pin down. The green glow and massive outbursts have flooded the area with dust, masking the nucleus behind a blurry haze. But Mars's orbiters can use spectral analysis and imaging filters to cut through some of that cloud and measure the object directly. They'll also study the chemistry of that strange green coma. Earth data points to diatomic carbon, but Mars instruments could detect additional exotic compounds, materials possibly forged in another solar system or under different stellar conditions entirely. These molecules could give us a direct look at the building blocks of alien worlds. This kind of opportunity has never happened before. Oumuamua passed silently, with no gas or dust to study. Borisov was more active, but stayed too far away. Atlas, by contrast, is loud, bright, and flying through a zone filled with tools ready to catch it in action. To scientists, this feels like a one-in-a-century shot. Billions of years ago, Atlas left its home system. Decades ago, we launched probes to Mars. And now, by sheer alignment, those paths are crossing. The data could completely reshape how we understand interstellar objects, their chemistry, their structure, and their behavior under sunlight. And it's all happening 37 million kilometers from a red planet armed with robotic eyes. Possible explanations. When a comet brightens sixfold in 2 days, glows bright green, and points its tail toward the sun, the obvious question is, what's going on? Scientists have been racing to explain 3I Atlas' strange behavior. And while no single theory fits perfectly, a few key ideas are emerging. The most straightforward explanation is an outburst. Comets are made of rock, dust, and frozen gases. As they heat up, pressure builds under the surface. Sometimes that pressure bursts through, causing jets of material to erupt into space. That can lead to a sudden jump in brightness, just like we saw with Atlas.
This was a really dramatic difference from what had been seen previously.
In this case, the outburst may have cracked the comet open, exposing fresh, buried layers that had been sealed for billions of years. But that doesn't explain the green glow or the tail pointing the wrong way. Atlas showed no signs of diatomic carbon when it was first detected. But after the outburst, it lit up in bright green, strong enough for backyard telescopes to capture. That glow almost certainly comes from the diatomic carbon molecules being hit by solar ultraviolet light. So where did the diatomic carbon molecules come from? One theory is that those molecules were locked away in deep layers of the nucleus, only released when the surface cracked. That would mean Atlas isn't just active, it's chemically exotic. Its interior could contain materials formed under alien conditions, in a star system far from our own. Fragmentation is another possible factor. If Atlas is breaking apart slowly, each fracture could expose new areas of volatile material. That could explain the sustained brightness and repeated changes. It might also account for the strange anti-tail, a stream of dust spreading along the comet's orbital path.
As insolation ramps up, volatile ices sublimate faster, dragging dust off the surface to form a brighter, broader coma and tail,
which just happens to appear sunward from Earth's point of view. Then there's the role of plasma physics. As Atlas sheds gas, some of it gets ionized and becomes plasma. Plasma reacts to magnetic fields in ways dust does not. If Atlas has enough ionized material, it could be forming complex magnetic structures, bending, twisting, or pointing in odd directions, like the apparent anti-tail. So which theory fits best? Most scientists agree it's not just one cause. The leading idea is that Atlas experienced a major outburst triggered by solar heating. That cracked the surface, releasing carbon-rich ices from deep inside. The result? A bright green glow and an intense surge in activity. The anti-tail, most likely, is a dust stream aligned with its orbit, visible only because of how Earth is viewing it right now. What's still unclear is the timing. Why did everything happen at once? That's the real mystery. The speed and scale of these events suggest we're watching processes compressed by Atlas's extreme velocity and interstellar origin. It's behaving like a comet, but one shaped by conditions no solar system comet has ever experienced. And while some have speculated about non-natural origins, every observed feature, however strange, still fits within known cometary physics. Atlas may be rare, it may be from another star, but it's not breaking the laws of science. It's just showing us how far those laws can stretch. A messenger that breaks every rule. In just a few weeks, 3I Atlas has shattered more expectations than most comets do in centuries of observation. It brightened 6 times faster than models predicted. It glowed green with compounds not initially detected. It formed structures pointing toward the sun, defying basic physics.
Even closer to the sun, astronomers were astounded to see Comet Lovejoy's tail glowing in extreme ultraviolet light as it approached the sun.
And it did all this while moving faster than almost anything we've tracked, compressing an entire cometary life cycle into weeks. But Atlas's greatest revelation may be this: the universe between stars is far stranger than the universe we know. 3 interstellar visitors, 3 radically different profiles. If this is just the beginning, if interstellar space is filled with objects forged under alien conditions, then everything detection rewrites what we thought we knew. By late October, Atlas will round the sun and accelerate back into the void, never to return. But in these brief weeks, it has shown us that our equations are incomplete. The cosmos is more diverse, more violent, and more unpredictable than our theories assumed. The next interstellar visitor could arrive next month or in a decade. It might be quiet like Oumuamua, chaotic like Atlas, or something entirely new. But we're no longer alone in cataloging our solar system. We're now tracking messengers from across the galaxy, and each one is expanding our understanding of what's possible. The rules are breaking, the visitors are arriving, and Atlas may be just the beginning. Thanks for watching. See you in the next one.